Hello everyone, my name is Bernie and I'm the lead architect at XX Labs working on the XX network blockchain. And I'm going to be doing a small governance walkthrough after a member of the community has proposed a quite important referendum. So we'll start here in the Explorer. We're connected to mainnet. You can see we're about 2.3 million blocks in, and we're going to head to democracy. Here's the referendum that's ongoing. So the way it works is users can propose proposals to the network, and then every 7 days, the proposal that has the most seconds will become a referendum. Then that referendum, there's 7 days for users to vote, and after the voting period is done, if the referendum passes, there's another 7 days until the change is actually activated or enacted, how we say it. So when a member of the community proposes a proposal and it's passed into a referendum, he'll have something called the supermajority approve. So the way this works is the referendum is easier to pass the more people that vote. So if only one person votes, you need 100% ayes for it to pass. The more people start voting as the turnout increases, it becomes increasingly easier to pass the referendum. So the point is that if everyone votes, one single vote could make the difference. But if less people than all the coin holders vote, you need more positive bias to make a change happen. So as you can see right now, there's about 6.1 million coins that are voted positively and 95 only voted against. And if you hover here, you can see how many coins need to vote one way to bring the referendum to the other side. So in this case, to make it fail right now, you would need more than 500,000 coins to vote no. While you could have like almost all of the ayes can go away and you would still pass. So what I want to show you now is a problem that people have mentioned on Discord quite a lot, is that you cannot actually see the full pre-image here. So this is something we are aiming to fix tomorrow probably. And the problem is, even if you copy and paste, you won't be able to see the full hash of the pre-image of this proposal. So the way we can actually find it out is by going to the developer tools and actually querying the blockchain state directly. So if we go here in democracy, we can first check how many referendums have been started so far. So there's 8. And now if we check here, we can see like referendum index 7 because it's indexed at 0. And this is the referendum that is ongoing right now. I can show you the previous one, 6, that finished and was not approved. It was the one to increase the validator count by 0. So here you can see the actual proposal hash. So this is the actual full value. And you can see that if I go here quickly to the release notes, it matches, let's increase this a bit, it matches the code that is here on the runtime info. So I know this doesn't mean a lot to many of you, but what I'm hoping to demonstrate now is exactly kind of like trying to explain what this does, like what is a runtime upgrade, what it does. So essentially, you can see here the current runtime is number 202. That's the spec version. And the runtime is essentially the blockchain's state transition function. So you have a given blockchain state, users can send transactions, those modify the state. The way those transactions are processed and how they modify the state is described by the runtime code. So that's a bytecode that runs in the WebAssembly on each and every node on the blockchain. You can see properties about the runtime in I always forget where, but there's a place where you can see metadata about the runtime. Here, sorry about that. So each runtime has a lot of information, like all the types that the blockchain contains, and all the calls, all the events, all sort of stuff that is used by developers. but we won't get a lot into that. So what I want to do now is I'm going to show you, I'm going to perform a runtime upgrade on the local network I have running right now on my machine. So I'm going to do this exact referendum, and we're going to see exactly what the new code does. So let's start by first connecting to my local node that is running on my computer. And you can see it's the same runtime and much earlier block because I just started this network some minutes ago. I also have some accounts, so since this is a local network, I essentially can control which accounts exist, how many coins they have, etc. So I've added all the accounts that are in tech committee and in the council. And you can see there's only 4 nodes running locally. Obviously they don't run CMIX, it's just a blockchain network, and that's what we're interested in today. And I can show you how a proposal is submitted. So I can go here and submit a proposal as a user, and I'm gonna grab this, and this is exactly what the member of the community did. And I just have to send a transaction, and now we have here the proposal. So obviously now we don't have 6 days and 23 hours to wait so it becomes a referendum. So the way I'm gonna show you how a proposal is done is by fast tracking it. So this is something that can be done by the council and the tech committee. But before that, I actually wanted to show you exactly which runtime codes are being run in mainnet and in this local network. So to prove that they're the same, I have a small Python script ready that queries the runtime code from mainnet and saves it to a file. And then we can hash that file. And now I'm gonna do the same, but getting this runtime code from my local network. So you can see here, I'm getting it from localhost. And now we're gonna do the same hashing, but on the local network runtime. And you can see this match. So essentially this means the blockchain I'm running right now locally on only 4 nodes has the exact same state transition function, so the same runtime code as our current XX network mainnet. So what I'm gonna do now is I'm gonna show you how this runtime upgrade is performed when it's coming from the council. So the way it works is the council needs to, some member of the council proposes a motion, and in that motion he has to say, oh, I want to propose an external majority referendum, and the proposal hash will be the one we know of already, and this becomes a motion in the council, and council members have to vote on this. This is the way we have performed a runtime upgrade before, because it was something that the team needed to push at the time. For example, if you recall, for improving the multiplier, the team multiplier. So I'm just gonna vote here with some council members. It needs 4 votes. I have 4 accounts. We'll wait for the votes to come through. Oops, forgot to vote with one of them. Let's unlock these sometime as well. Okay, now we'll close the proposal. So the motion in the council has passed. You can see here, approved. And now you will have here exactly the same proposal. However, the only difference is, since it comes from the council, the tech committee can decide to fast track this proposal. And when you do that, the tech committee can essentially decide what is the voting period and the delay. So this means that you can enact something faster. For example, you can specify a voting period of 1 week, but then you might want the enactment to happen 1 day instead of 7 days after, like it does when it's a public referendum. So what we're gonna do here for testing purposes, we're gonna set this delay to be a smaller number. This is specified in blocks. So if you remember, each block is around 6 seconds. So 100 blocks will be 10 minutes. Maybe that's a bit too long. So maybe we'll do 50 blocks. Yeah, I think that sounds good. And for voting, this is easier if we do it faster. Just 1 minute. So let's see. Now what that did is proposes a motion in the tech committee. And when the voting period is smaller than a specified constant, which we have defined to be 3 hours, it needs unanimity from the tech committee. So every single member has to vote. In this case, we have 3 members. All 3 have to vote. Oops, misclick. So now we'll close this proposal, and we'll see that now our external proposal has become a referendum. And there's not much time left to vote, so I'm just gonna vote so that it passes, and then we'll have about 6 minutes before it actually activates. So what I want to show you now is what many of you must be wondering. Since this is the same runtime code as mainnet, I can try to do a transfer from my user account to a council member. And this is probably what some people have experienced when they've tried to do a transfer. So what does this mean, call filtered? If we go here on the release notes, and if we actually dive into the code, this probably doesn't matter for many of you, but this base filter here is a call filter. So these filters calls that users are allowed to make. These are called extrinsics. So they're transactions that are signed by users of the blockchain and submitted. Within the runtime, modules or palettes can call each other. So for example, a staking palette can still call balances to transfer your staking rewards, and that's how you've been receiving them over this time. But since there was a transfer freeze at Genesis, any calls to the balances module were not allowed. So what this code change does is removes that from disallowed, false. So when it returns false, it's not allowed, and moves it to this side where it returns true. So essentially, calls to the balances module will be allowed with this new runtime code. And let's check back here. So the referendum has now passed, and we have 4 minutes here. Great. So the pre-image here just stays the same, but when the proposal will be enacted, you actually need to know exactly what was proposed. So basically this is just a hash of what was proposed. So what we need to do now is submit the image. And to do that, I'm going to go back here and I'm going to download this runtime code. And now I'm going to put the image on chain. So the way we do this is how it's described in the wiki page as well, is you click on the image button there, and anyone can do this. Why? Because only if the image is submitted matches exactly the hash that was already approved can this work. So if someone submits a different code now, you can try 0x something. You can see it still stays red all the time because it does not match our hash that was approved back here. So the only way we can actually make it match is let's upload the file. So to do that, we're just gonna drag and drop the file that we downloaded, and you can see the pre-image hash now matches, so you can submit this pre-image. Now this is a quite large transaction because the runtime code is almost 1 megabyte. So it says here that the fees will be quite big, like 83 XX coins. But this is not a problem because this is an imminent pre-image. That means the referendum was already approved. So this is something that has priority to be on chain because it's necessary for the referendum to be executed or enacted. So when we sign, we actually need to have those 88 coins. But if we go and check this transaction, you can check that the coins were removed from, so they were withdrawn from the account to pay for fees, but then they were deposited back. So there was actually no fee for this transaction. And now we just have to wait. Okay, and now we're back. We're almost there. I had to skip a bit because there was almost 2 minutes of silence. And we will see now the referendum will be enacted. So this is a runtime upgrade. And these usually are quite large, so you can see it takes a while for the block to actually be produced. And it has happened. So you can see it was executed. And now that we know the runtime has been upgraded, you can check here. Now it says 203 instead of 202. And usually when the runtime upgrade happens and you're connected to the Explorer, some stuff might break. So what I always do is refresh my Explorer when that happens. And all my accounts are still here. So let's try to do a transfer. And we'll see it's in the block. So we can go here and we can see the transfer from the user to the council for 1,000 coins. So our chain uses 9 decimals. That means there's 9 zeros appended to any value. So this means you put the decimal point here, so it's 1,000 coins. You can send technically 1,000.000000001. And here you can see how much was the transaction fee and how much of it goes to the block producer as well, and how much was the weight of this function. So yeah, this is what I wanted to show you guys, and hopefully this sheds some light on how the governance proposals work, and especially how a runtime upgrade is performed. So what usually happens when you propose something is you would basically most of the time submit the pre-image first. You don't do it in this case because it's a very big file. So if I try to show you that, if I try to upgrade, put the runtime on chain, it's so large it's going to tell me, oh, you need to reserve 8,000 coins just to keep it on chain. So that's why we do it after the fact. So if the referendum passes, we will actually put it on chain because it will be enacted. But before it passes, when it's being voted on, we don't need to do that. But for example, if we're doing a referendum to increase the number of validators, so let's say we want to increase to 40 validators, and that's quite cheap because it's a very small call. So you can simply submit the pre-image, and then you can submit the proposal. I should have grabbed the pre-image, but I didn't, so now I need to go get it. Here it is. So when you submit the proposal and now you put the pre-image, since you already put the image on chain, it already knows what it is, right? So you can see exactly which call it is: staking, set validator count, and 40. And when it becomes a referendum, the same happens. But the big difference here is that the runtime code is quite large, and you don't want to have to lock up 8,000 coins just to keep that image until the referendum happens and passes. So yeah, this concludes what I wanted to show you guys. We can go back to mainnet and look at the referendum again. So remember, if you want to grab the pre-image before we update the Explorer, we might do it in the next couple of days. You can always come and get all the referendums. If you don't include this option, you can get all the referendums, and you can see everything that has happened before and the one that's ongoing now. And here is the proposal hash, which matches the one here in the release. So yeah, Hopefully this sheds some light into the governance processes of substrate-based networks, and more specifically XX network. So see you guys on Discord.